This question, which written the equation of the curve, is given as a y equals to x e to the power minus x by 2. Then they would ask us to show that dy by dx is that one. So we needed to apply the differentiation here. Let me apply the differentiation. If I write there dy by dx, here is the two terms, which is x e to the power minus x by 2. If we apply here d by dx, so two terms are with the multiplication form, we needed to apply the product rule. If you don't know the product rule, please click on the I button from the top right to see the product rule in detail. So d by dx of e to the power minus x by 2 e to the power minus d by dx of x. So we're going to differentiate now x into e to the power minus x by 2. This is also the exponential differentiation. See from the I button in detail about the exponential differentiation. E to the power minus x by 2 into, we needed to differentiate the x by 2, then we got from here minus half, then plus e to the power minus x by 2. If we differentiate x, we got from here 1. So we needed to write the full thing, e to the power minus x by 2 minus a half x e to the power minus x by 2. Let you take common e to the power minus x by 2. The remaining part is, you can write 1 minus x by 2 e to the power minus x by 2. If we take e to the power minus x by 2 common, so inside of the bracket we can make LCM, so it would be 2 minus x divided by 2, then e to the power minus x by 2. Finally we can write from here by taking half common, half into 2 minus x, then it would be e to the power minus x by 2. Question is asking to show here, show that one. So we already got the same thing, so you can write here shown. This is our first part of this question A. The second part is asking us to find an expression of d square y by dx square. So we needed to differentiate that expression again. For differentiating of this expression and differentiation of the expression, which what written here is the same thing. Okay, let me apply here the differentiation again. D square y by dx square, dx square we needed to write d by dx of, which the expression is 1 minus x by 2 e to the power minus x by 2. We needed to apply here the quotient rule again, sorry, product rule again. So let me apply the product rule. 1 minus x by 2 d by dx of e to the power minus x by 2 plus e to the power minus x by 2 d by dx of 1 minus x by 2. 1 minus x by 2, then e to the power minus x by 2 into minus half from the first part of the differentiation, and e to the power minus x by 2 into minus half from the second part of the differentiation. So let me remove the bracket now. From here you can write here, so minus 1 into half, so minus half e to the power minus x by 2. Then next part is plus x by 4 e to the power minus x by 2, and here is again minus half e to the power minus x by 2. So minus half, it makes the minus e to the power minus x by 2, then plus x by 4 e to the power minus x by 2. So we can simplify it by writing like this: e to the power minus x by 2 you can take common from there, then the remaining part is x by 4 minus 1. So this is our expression for d square y by dx square for the second part. Let me go for the other part of the question. It is written here, the curve has a stationary point at M, find the coordinates of M. To do that, we needed to consider dy by dx equals to 0, because for doing the stationary point, turning point, maximum point, minimum point, we have the same working. we need to consider dy by dx equals to 0. So we already have the expression dy by dx, which is, this is our dy by dx expression. Let me use that expression here. So we can write here half 2 minus x e to the power minus x by 2 equals to 0. So from here, the first part is a constant, so only the factor is 2 minus x equals to 0, and from there we got x equals to 2. We would not consider e to the power minus x by 2 as a 0 because it is never possible or not applicable. So this is the x value of the stationary point. Now we needed to find out the y value because it is written here the coordinate. So for doing that, we have to put this x value in the main equation to get the y value. So our main equation is x e to the power minus x by 2. Let me write here our main equation y equals to x e to the power minus x by 2. So we are going to put the x equals to 2, then it becomes 2 e to the power minus 2 by 2, which is 2 e to the power minus 1. We also can write 2 by e. So our coordinate of AM, we can write x value is 2 and y value is 2 by e. So this is our stationary point coordinate at point M. Now we are in the last question. Determine the nature of the stationary point at M. For seeing the nature of the stationary point, we need to double differentiation. We already have it, d square by dx square, and that is our expression. In this expression, we are going to put the value of x equals to 2. So we can write here when x equals to 2, when x equals to 2, our d square y by dx square is e to the power minus 2 by 2, 2 by 4 minus 1. So e to the power minus 1, and inside it is minus half. So you can write it minus half or minus 1 by 2e, because e to the power minus 1 we know we can write it 1 by e. So it's completely a negative value, so we can say m is a maximum point. This is our conclusion of this question. Stationary point.